Move here and there in your home, when you pass from one room to another room in your home, then your motion is also non-uniform. Motion of house slide, it moves here and there, zigzag way. It is also non-uniform. Means, what do you mean by non-uniform motion? In a particular time interval, distance covered by the object is not same, then it is called non-uniform motion. And in a particular time interval, if distance covered by the object is same, equal, in equal time interval, distance covered by the object is equal. In equal time interval, distance covered by the object is equal, then it is called uniform motion. As for example, motion of the second hand of a clock in equal time interval. Here time interval is only 1 second. Okay, after every 1 second, after each and every 1 second, the second hand cover equal distance. So it is the example of uniform motion. In general way, in our daily life, in our routine life, we perform always non-uniform motion, not uniform motion. If you fix the fan at 4 speed or 5 speed, then it moves in a particular time interval and the distance covered is also same, then this motion is also called uniform motion. Okay? Now in 7th standard, I think so that in 7th standard, you have learned about speed. Do you remember it? Can you recall it? What do you mean by speed? Speed is what? Speed equals to, in common language, you thought it is a what? Distance upon time. This is the formula to find out the speed. And the definition is what? Distance traveled by the object per unit time is called speed. Distance traveled by the object per unit time is called speed. Now speed is denoted as v. If distance is denoted as v and time is denoted as t, then we say that v equal to d by t. Now in 9th standard, distance is also denoted as s, d or s. You can write s also. So here we use s. Okay? V equal to what? Distance upon time, distance traveled by the object per unit time. That is distance upon time, s upon t. Now what is the unit of speed? Unit of distance, if you take meter per time, is measured in second. Meter per second, that is called SI unit. What do you mean by SI unit? This is the Latin language. The full form is standard, the international. In English, we say international standard. In Latin language, it is called standard, the international. Means this unit is accepted as internationally, that is the SI unit is meter per second. You can measure centimeter per second also, or you can measure in kilometer per hour also. Okay, bigger unit, kilometer per hour. This is about speed. Now, can you say that speed is absolute or relative? To explain speed, reference is needed. If not, then absolute. If yes, then relative. Right? Think about speed. Speed is absolute or relative. See, suppose someone said that my dad drives car with 140 km per hour. Is it true? Maybe, may not be. It may be true for a while, for a few seconds, but not for whole journey. For whole journey, it is totally wrong. Right? Because someone starts with 0 km per hour speed and then slowly, gradually increases. After that, when it reaches to the expressway, just like the open highway, then it maybe reaches to 120, 140, but suddenly suppose there is a hurdle, then he has to decrease the speed. Means for whole journey 140 km per hour or 100 km per hour is not possible. Never possible. Right? So, speed, if someone said that about speed, then we can understand. Yes, we can understand that speed of the bullet train is so and so, speed of this car is so and so, speed of the jet plane is so and so, that we can understand. It doesn't mean that for whole journey, it means the highest speed. That's why we can say that speed is what? Absolute physical quantity. Here explanation or reference is not required. But once you plunge into velocity, velocity is also denoted as V. Velocity means what? Not distance, but it is called displacement upon time. The difference is what? Distance and displacement. Distance is an absolute physical quantity. Time is also absolute physical quantity. But here velocity means displacement upon time. Here we define that distance traveled by the object per unit time is called speed. Velocity means displacement of the object per unit time, that is called velocity. And when there is displacement, then there must be direction. Because displacement is relative physical quantity. And which reference is required for the explanation of displacement? Direction is required. So here also we said that displacement means direction. And if it needs direction, then it is called relative physical quantity. It is called relative physical quantity. So displacement, it is also denoted as S and time denoted as T. The unit is centimeter per second or meter per second or kilometer per hour. Once again I should say that meter per second is the SI unit. Standard the international. Meter per second is SI unit. So suppose kilometer per hour is given for in the numerical, then you have to convert it into meter per second. The next question, how we can convert kilometer per hour into meter per second? It is very easy. Conversion of kilometer per hour to meter per second. You know the relation between kilometer and meter. You know the relation between hour and second. Okay? See here, kilometer per hour. 1 kilometer means 1000 meter. Per 1 hour means 3600 seconds. So 2 zeros are cancelled. 10 upon 36 meter per second. You can divide by 2. 2 5s are 2 18s are. That is 5 upon 18 meter per second. 1 kilometer per hour means 5 upon 18 meter per second. So 5 km per hour means 5 into 5 upon 18. 100 km per hour means 100 into 5 upon 18. You can change it with the help of this. Is it okay? Do you understand about speed and velocity? Just like distance and displacement. Okay? Now, the second thing is average speed. I told you just before one example that if your dad drives a car 100 km per hour, then it is not for your whole journey, it is for a few moments, few seconds, few minutes only. Okay? And it is not constantly. It may be some increase or maybe some time decrease. So at that time you have to find average speed. What do you mean by average speed? See here. Average speed is denoted as V average, VAV. Average speed is what? Total distance upon total time taken. You have to remember the formula because it is necessary for numerical, it is necessary for derivation also. So average speed, which is denoted as V average, the first two letter of average, AV. Definition is what? Total distance take upon total time. To cover total distance, how much time is taken? That is called as average speed. Average speed equal to distance is denoted as S, time is denoted as T. Once again, measure in meter per second. Here we should use only SI unit. Okay? Same manner. What do you mean by average velocity? V average again. See, the symbol is same. The minute change is there, minor change is there, and that's why this which create the problem. Okay? So average velocity is what? Total distance, total displacement upon total time taken to travel or to cover that displacement. Again, V average equals to total displacement upon total time, meter per second, the same. But if you want to distinguish between average speed and average velocity, then there is also another formula of average velocity. Or average velocity, V average equals to final velocity minus initial velocity upon plus divided by 2, that is average. Final velocity plus initial velocity divided by 2. Remember, final velocity is denoted as V, initial velocity is denoted as U upon 2. This is the formula to find out average velocity. Final velocity plus initial velocity divided by 2. Just like your first term marks, your second term marks divided by 2, this is the average marks. In this way, final and initial, the sum of these two divided by 2, that is called as average. Remember this thing also. Okay, so you have learnt about physical quantities, absolute and relative, right? After that, distance and displacement, time. After that, speed, velocity. You also learned about motion. What do you mean by motion? Average speed and average velocity. Average speed is used, okay, when there is no fixed speed. If speed is varied, increase or decrease, or sometimes less or sometimes more, then use average speed. Same way, you can use average velocity also. Here, the formula used for the average velocity is V plus U upon T. V stands for final velocity, U stands for initial velocity, and divided by 2. Okay, now once again we are going to learn about motion. Uniform motion and non-uniform motion. Here we are also going to learn about their graphs. Graph also. So, let us start with uniform motion and their graph. And then we see about different varieties of graph. Okay? See, uniform motion graph. Graphs of uniform motion. You know that uniform motion means what? In equal time interval, distance covered by the object is equal. Then it is called uniform motion, right? So here you have to draw the graph of distance versus time graph. As for example, we take the data. First we start with time and then distance. At 8 o'clock, as per our example, as per our illustration, at 8 o'clock you start your journey, that is the distance covered by the object is 0 kilometer. After half an hour, that is 8:30, the distance covered is 10 kilometer. At 9 o'clock, the distance covered is suppose 20 kilometer. At 9:30, the distance covered is 30 kilometer. At 10 o'clock, the distance covered is 40 kilometer. Okay? And if you draw the graph, we maximize the first quadrant because both terms are positive. On the x-axis, you have to plot most out of these two, which one is dependent. Actually both are independent, but out of these two, which one is the most likely independent? Independent is time. So you have to plot time on x-axis and plot distance on y-axis. That's why it is called distance versus time graph. At 8 o'clock, at 8:30, 9 o'clock, 9:30, 10 o'clock, maybe 10:30, here 0, 10, 20, 30, 40, okay? 8 o'clock 0, 8:30, 10, 9 o'clock 20, 9:30, 30, 10 o'clock 40, and so on. So graph is straight line. Why it is straight line? Because it is uniform motion. So from the graph you can say that this graph is of the object performing uniform motion. If there may be non-uniform motion, then non-uniform motion graph will be maybe start with 0, then its speed increases, then maybe steady, maybe decreases, increases, like this. So this is non-uniform motion graph. Always graph of non-uniform is zigzag, right? So from the graph we can deduce that the graph is of uniform motion object. Second thing, from the graph you can find out at which time distance covered by the object is how much. Suppose at 9 o'clock object reaches at, or object covers how much distance? So at 9 o'clock, this is the 9 o'clock, move in this direction and then move like this, 20 kilometers. 9 o'clock 20, if data is not given, then also from the graph we can find out the distance covered by the object from time. If time is given, at a particular time, distance covered by the object is known. Vice versa. To cover certain distance, time taken by the object is also known. To cover 30 kilometers, how much time taken? At 9:30 it reaches to 30 kilometer distance. So from distance you can find out time, from time you can find out distance. Is it okay? In between certain time interval, suppose 8 o'clock to 9:30, 8 o'clock to 9, 8:30 to 9:30, 8:30 to 10 o'clock. In between certain time interval you can also find out distance covered by the object. As for example, at 8:30 it covers 10 kilometer and at 10 o'clock it covers 40 kilometer. In between this one and a half hour, the distance covered is 30 kilometer, 40 minus 10. So in this way also you can find out. Okay. and the most important use of distance versus time graph is what? You can find the speed of the object. How you can find speed of the object? To find out the speed of the object, you need to find what? Slope of the graph. What do you mean by slope of the graph? Slope means not this. Slope means what? See, select any 2 points. This is the physics. Remember this thing. Select any 2 points. Suppose I want to select this and draw a right angle triangle. I name it ABC. Is it okay? Now find out BC. What is the length of BC? B means 930. C means 9. This is half an hour. Half hour. What is a distance between AB? So B is 20 and A is 30. So this is 30 minus 20 means 10 kilometer distance. This is kilometer. This is in hour. So slope means what? Speed. Slope is called what? Speed of the object. Speed means distance upon time. Distance is 10 kilometer. To cover 10 kilometer, time taken is half an hour. You know, denominator of denominator is numerator. So it moves up upon 1 kilometer per hour. So 20 kilometer per hour is the speed of this object. From the data also you can derive at 8 o'clock 0 kilometer and 9 o'clock 20, 8 to 9 1 hour, so 20 minus 0 20 kilometer. So 20 kilometer per hour the speed. So from this uniform motion graph, distance versus time graph, question may be asked about write the uses of distance versus time graph. You can write in this way. At a glance, we can find out the nature of motion, whether it is uniform or non-uniform. Is it clear? If it is uniform motion, then the graph is straight line, and if it is non-uniform motion, then graph is zigzag. So from the graph we can find out the nature of motion. Second, from the given time we can find out the distance covered by the object. Third, vice versa. To cover certain distance, time taken by the object is also known. Fourth, in between certain time interval, the distance covered by the object is also known. Fifth, from the slope of the graph, we can derive speed of the object.